Question number 3, we're looking at the amount donated to charity between 1995 and 2003, where t equals 5 indicates 1995. So this one, the dates have already been converted to smaller numbers for you, and they just chose t as being 5 as 1995, so we can quickly see here, if this is 9, that's going to be 1999. So that's just the reason behind why we started at t equals 5. So I want to know, using the regression feature, determine the R2 values for each of those so we know which one is going to be the best predictor or the best fit. So let's just start by going through these. So we'll go to Calc, Edit, actually Stat Edit, and you can see I've already typed in my values here for this table. And we want to double check just to make sure we've got the same number of values in both L1 and L2, which we do. So we'll go to Calc, and we'll do a linear regression. And I'm not asking for anything in the future, so I don't need to store this into Y1. So let's look at linear regression. We can see my R squared feature is going to be 0.9485. Do the same thing with quadratic regression. R squared is 0.9814. Cubic regression, 0.991376. We're looking next for quartic, then logarithmic. So quartic regression, there's my R squared, 0.993717. Then we're looking at logarithmic regression. Yeah, logarithmic regression, which is the ln regression. And we're looking there at the R squared, so 0.9736. And then finally, exponential regression. So 96299. So when you look at this, which one is the best fit? It's probably the cubic or the quartic, because you see those are both 99% in terms of predicting future values. So since the R2 is really the only thing that we have to compare all the different pieces with, you saw linear had R, logarithmic had R, exponential had R, but these ones didn't. We can just really use R squared as being the only piece we can easily compare, which is the 0.99. So cubic or quartic would be the best fit. Question numbers 4 and 5, plugging these values into the calculator. How would we do that? The first one here, going from 5 to 512, what we do for that is we click on second list, and we go to math, and we choose option number 5, which is sum. And we want sum of the sequence. So we'll once again do second stat to get to the list, and we'll do options of the sequence. So just remember what the format is for this. It's sum of the sequence. First you put in your expression, so in this case it'll be 3x plus 7. Then we plug in our variable. Then we plug in our lower bound. Then we plug in our upper bound. So that's what we're looking at. So we've got sum of the sequence of 5x plus 7, comma x, comma 5, comma 512. And there's my sum. 660,146. And then how do we do it with an infinite sum? Well, it's going to be the same idea. It's going to be sum of the sequence, but we don't have a lower and an upper bound. We know we have a lower bound here, which is I should be I equals 1. We're going to go from 1, and let's put in a large number. Maybe 200 will be good. So we want sum of the sequence, and my sequence is going to be 0.1 raised to the x. 1/10 is 0.1. Then we've got our value right there. So for this one, it'll be sum of the sequence of 0.1 raised to the x. Then we plug in our variable, and then 1, and 200. We should get a pretty good number result for that. So let's see what happens as it thinks. And you can see it's going to be 0.1 repeating, which would be my sum.